In this video, we're going to continue our examination of the non-parametric approach to evaluating paired responses, and we're going to use the sign test, and we're going to build off the previous video on the salaries paid to professional athletes. And so really what that study was evaluating wasn't the professional athletes per se, but the public's impression or perception of professional athlete salaries. So in this study, we evaluated the response in 10 people, and that response was the answer to the statement of professional athletes making too much money. So using that Likert scale, we see that we have 10 participants, and they all provided a pre-test rating that you can see many had rated strongly agree, a number had also rated agree. Now, so following the pre-test, all 10 individuals underwent a education program essentially covering the statistics of professional athletes' salaries, of what they actually make. And then the same individuals were reevaluated to the response to the statement of whether professional athletes make too much money. And once again, these are paired responses. So these are the responses in the same 10 people. And you can see how in a number of the individuals, their responses changed. So in the first participant, prior to knowing what the actual salaries were, they strongly agreed. But after learning of the actual salaries, now they just simply click or check agree. And we can see a range of different responses. So in participant number 5, their opinion did not change. So the first step is to subtract post-test from the pre-test. So it's a 1 subtract 2, but we only put the sign. We don't put the numerical value. So 1 subtract 2, of course, is -1, but we just drop the 1 and we just leave the negative sign. And we do that for each of the paired responses, and so we can see that we have a larger number of negative signs and only 1 positive sign, and we see that there were no changes in 3 of the participants. So what this does is this establishes a new sample size, if you will, of n equals 7, and that's the number that will be used moving forward to establish if there was a statistically significant change from pre-test to post-test. So with the sign test, once again, the same participants were evaluated twice, and what we're evaluating is the null hypothesis that the number of positive signs that we saw on the table on the previous slide is going to equal the number of negative signs, or essentially the probability of positive will equal the probability of negative, which will be 0.5. So the first step we've already completed on slide 34, where we determine the different scores for each pair, but we only note the positive or the negative sign. We don't put the actual value. And then we determined the n, and we determined the n to be 7, and those are the number of non-zero scores or non-zero signs. So we had 3 people that did not change their response. So our new n is equal to 7, and that's the value we'll need to move forward on the next slide. Now, because we have 2 values, the number of negative signs and the number of positive signs, we take the smaller of the 2 values, so the fewer number of signs, and that was the positive signs. We only had 1 positive sign on slide number 34. And then we assign that value as the actual test statistic x that we will use to evaluate for statistical significance. So we set x equals to 1, and this is based on the actual data, whereas the n equals 7 is going to be used to determine the critical value that we'll see here on the next slide. So at the bottom here is we have the sign table, and what we need to do is look for our level of statistical significance and our new n. And so the goal here is to determine if the x equals 1, our test statistic, is in the critical region. And if x is greater than the critical value, our test statistic, we haven't found our critical value yet, we'll do that here in a moment. If it exceeds the critical value, that indicates the number of positive signs exceeds 0, which in our case will be the critical value, but we'll locate that here shortly. And what we will determine here is that our test statistic x1 is not in the critical region. And if it is not in the critical region, we do not reject HO. We do not reject the null hypothesis. So we state here that the educational program did not significantly change the opinion of the sample. So to find that, we use, unless stated otherwise, we always go with the two-tailed test and the 0.05 level. So we see a range of critical values for n equals 7. We zero in on the 0.05, and that puts us at a critical value of 0. And so we can see how at a low sample size, the numbers don't change very much until we get to a level of significance of 0.2 as opposed to 0.5, but once again, the 0.2 is a very liberal value that we don't use very often. The 0.05 is the value that is used most often. Last point here to make about the sign test as a reminder that even if the results were found to be statistically significant, this does not indicate the magnitude of the change. It only indicates that there was some change in opinion of people completing the questionnaire. So this ends our video here on the sign test.